Okay, so so on GitHub, I have a repository going for this class, and I think because I'm like constantly making little updates and stuff, instead of like having to re-upload the file to CCLE and stuff, I'm going to encourage you to clone this repository onto your machine, okay? And basically you'll go to the repository and you're gonna click this option that says clone, okay? And you'll copy that link, and then in Git, you're gonna type in git clone and the that link addresses link, okay? And then it will download everything from the repository to that folder wherever you've made it. And then so you would type in git clone, and then you'd put in this address, right? Okay, I'm not going to do it because I already have it on my machine, okay? And then once you have it on your thing, you're going to just, to update, you'll just do a git pull, okay? And that'll pull any updates, okay? If you try to, I mean, you can make changes and make commits, but then you won't be allowed to push those commits to my repository online, right? Because you're not authorized to do that. So so you won't be able to do that. But you can still do git pulls, and what git pulls will do is it will merge the changes that I've pushed to the changes that you've made on your thing. So if you want to add notes to some notebooks and stuff, that's fine. My recommendation, though, is if you I don't know, I would say make a branch or something if you're going to make changes, okay? Rather, because you could pull the changes from the server, and that will go into the master branch and things. And if you want to make changes, then you can branch off. It's just, I think later on at a certain point I'll have to talk about what do you call it? Resolving merge problems with in notebooks, because in notebooks it'll crash the notebook if you have like a merge conflict. Okay, so anyway, I think I'm gonna force you guys to use Git a little bit in that way. Okay, to get course materials, you're gonna have to do Git pulls. I mean, of course, you can always just go to the notebook and look at it directly. And then, and I'm hoping by this point you have gotten Anaconda and everything installed in your local machine. And let me get Jupyter Notebook started. And we'll take a look at more, I don't know, some basic Python stuff, okay? In the beginning, it's very, I don't know, rudimentary, right? We got to cover some of the basics of the language. So we're going to cover some syntax and data structures today, and then we'll get into some programming stuff. Okay. Oh, I should mention, on Monday, we'll have a quiz. Short quiz at the beginning of class. It'll cover Git, okay? So review your Git stuff. And like Git add, Git commit, Git push and pull and branch and merge. I don't know, diff status, things like that, right? Just commands there. Okay, let's take a look at our notebook. Are you guys able to see this? Okay, so great. All right. So we'll talk about Python syntax. This is based on Jake Vanderplas's thing. He wrote the Python Data Science Handbook, or Python for Data Science Handbook. Okay. But anyway, let's talk a little bit about this. Okay, so comments, you guys I think already know. You put a little hash mark, it's not going to run. Okay. when we write lines in Python, okay, much like R, just the end of a line means is the end of your statement. Okay, if you've taken like pick 10 or something where it's a C based, you got to end everything with a semicolon. Okay, we don't have to do that here. All right, so this will run just fine. Oops, running all of these things. Okay. All right, so if I have x equals 5 and I say print x, that runs, okay? If you want, you can use semicolons, much like R, if you want to include multiple short statements in one line. So if you're going to do like a bunch of, I don't know, short little statements, you can separate them out here, okay? So here I've got x equals 6, semicolon, or I have y equals 6 and semicolon z equals 7, and that's one line, and then the next line we have here, okay? On the other hand, if you have like a long line and you want it to continue on over multiple lines, you can use a backslash, okay? And so a backslash will tell Python, I'm not done, look at the next line, and continue on, right? So here I've got 1, 2, 3. Without the backslash, it would assign 6 to the value A. But I've got the backslash, so it goes to the next line. It goes, oh, we're going to add 4 and 5 to it, and it figures out that it's 15. Okay, or you can just use parentheses, all right? And if you use parentheses, it'll know I got to keep going until the end of the parentheses, right? And or other things like if you're defining a list, and we'll get into lists in a moment. Lists are defined with square brackets, and obviously if you start defining a list, it's going to read multiple lines until it reaches the closing square bracket to say that we're good there, okay? So you can try all of these things out. Okay. An important thing in Python is that indentation is how we define code blocks, okay? So in R, if you had like an if statement or a for loop or whatever it was, you'd use curly braces to say like these lines of code go together, and how they were indented didn't actually matter, okay? You could have them all in line against the edge, or you could indent them, the stuff. As long as it was inside the curly brace, it didn't really matter. With Python though, there's no curly braces, and indentation is how we determine which lines belong to the if statement or which lines belong to the for loop, okay? So the effect though is that it makes it readable, okay? Is that by having indents, you know exactly which lines belong to some kind of statement, okay? So when you have a code block, there's always going to be a colon in the preceding line. Okay, so if there's an if statement, it's going to end with a colon, and the associated indented lines will be associated with that. Or if you have some kind of for loop or something, you're going to have a colon there. Okay, so here we have x equals 8, and then if I say if x is greater than 5, print x is greater than 5, print x, and print hello. Okay, and so when we run this, these two lines are associated with the if, okay? And this line, print hello, is not, okay? So this line, print hello, will get run no matter what, whereas these lines are only run if x is greater than 5. So when I run that, indeed, it tells me x is greater than 5, it prints out 8, it prints out hello, it prints out the value of x, okay? Over here, I've got x is equal to 4. I run the exact same code, and these two lines are not associated. Are associated with this, and so they are not run. Okay, which means you know, if I insert a statement here, just removing an indent, okay, will drastically change what happens. Okay, and you know, the nice thing about IPython is that it's smart enough. So if I write a statement, if x is equal to 0 or something, and I write a colon, as soon as I hit enter, it's going to indent the next line for you. Okay, So it's a nice thing, and only until you backspace out will it do this. Okay, so what will happen if I run this? X is 4, if x is greater than 5, print x is greater than 5, print x, print hello. So when I run this, what's it going to output? So it's basically the same thing. All I've done is I've changed the indentation here. Yeah, what'll it do?
4 and hello.
It'll print 4 and hello. Yeah, exactly. Okay? Because only this line, x is greater than 5, is associated with the if, and the print x is not, so it's going to be run no matter what. Okay? And so, you know, when you're new to Python, you know, it feels weird because these two things look almost exactly the same. The only thing is there's an indentation here and there's not over here, but the results are different. Okay, so that's something to look out for. And so, you know, if you do, sometimes if you copy and paste code from like a PDF or something, the tabs get lost or the tabs get messed up in a copy and paste thing. And an indentation and the tabs are incredibly important in Python. So you, when you copy and paste something, you have to go through and read everything and make sure that all of the tabs and the indentations are preserved. Otherwise, the code's going to behave in a way that it wasn't intended to, right? Because, you know, PDFs are weird. It's not regular text, and so a lot of these things get lost. Okay, let's talk the data types. And here I'm going to just start off with kind of the basic data types as far as values go that we store. And this is much like R. We've got integers, we got floating point numbers, strings, booleans, and complex numbers. I think there's also like bytes, but you know, we don't really use that. And again, probably the 4 that you're going to encounter use the most will be integers, floats, strings, and booleans. Okay, so R called these things logicals, but in Python they're bools, and so that's what we have. Okay, we got ints and floats, strings and bools, and you know, again, one thing, an important distinction between Python and R is R has a built-in missing value. It has an NA for every single type. You have a missing for type logical, missing for type integer, and you have a missing. We don't have a missing thing in Python. Okay, you have a not a number, which is used a lot of times for missing, but we often don't have we don't have like a regular old missing. Okay, so if you ask what is type 3, okay, if there's no decimals, Python's going to treat it as an integer. Okay, so you say what's the type of the number 3? It's an integer. Okay, you put in a decimal 3.0, then it becomes a float. All right. So here I've got A is 10, B is 2, and then I'm going to do division. I'm going to do 10 divided by 2, and 10 divided by 2 is 5, but the division operator will always return a float. Okay, so you can do 10 divided by 2, even though 10 divided by 2 is an integer 5, okay, as far as mathematically speaking, in the computer, or at least in Python, division will always return a float. And so when you ask what is the value of C, it's going to print out 5.0. Okay, and so if it's a float, even if it's a whole number, an integer, as a float, it gets reported as it's going to put in 5.0, just so that visually you can easily distinguish between floats and integers. Okay, if it's an integer, it will display just 5. If it's a float, it will display 5.0. So Python will always display a decimal if it's a float. Okay, even if it's a whole number there. Okay, so division always returns floats. Multiplication doesn't necessarily return floats. Okay, depending on the inputs. So A is 10 and B is 2, okay? So if I do D is A times B, okay, it will return 20 without a decimal, and it's an integer, okay? On the other hand, if I did 5.0 times 2, that's going to return 10.0, and that's a float. Okay, so floats times integers will be floats. Integers times integers will become integers, okay? And floats multiplied by floats will be floats. Okay, here's an interesting thing. Integers in Python are variable precision, okay? So you can do these giant integer calculations, and you won't run into an overflow error. Python will allocate the needed memory to do this. So I can raise 2 to the 1023 power, and it gives me this big number that I don't even know how to read this, right? So you know, you have that. Whereas in R, the integer type is restricted to 2 raised to the 31st power minus 1, okay? Because it uses 32 bits, and so half of these are positive and half are negative, and one of them is 0. So you have this 2 raised to the 1024 is a huge number, and the computer calculates it. Okay, this is impressive. So you can do like, I think like if I tried to do like 100 choose 50 or something like that, I don't think R can handle something like that. Let me just try really quick. Oops. So I think I can do 100 factorial. Okay, maybe not. All right. Okay. Forget what I was talking about. Okay, but you can do these big calculations. Okay. On the other hand, floats are 64-bit floating point numbers. IEEE 754 specification for 64-bit numbers, and so the maximum value you can have for a float is a little bit smaller than 2 raised to the 1024. Okay, so 2 raised to the 1023 will tell me it's 8.9 times 10 to the 307 power. Okay, which is exactly what we have here. But then if I try to raise it to the 1024 power and it's a float, I get an overflow error. Okay, it's too big to be stored as a 64-bit floating point number, so that gets killed there, right? And I think, did anyone have 102A not with me? Everyone had, okay. Okay, so I think in 102A we talked about how like 0.1 plus 0.2 doesn't equal 0.3, right? And so the standard warnings about floating point numbers apply here, and so if I have Q is 0.1, R is 0.2, and S is Q plus R, okay, is S equal to 0.3, that's going to return false. And interestingly enough, at least on my machine, it prints out that the result of 0.1 plus 0.2 is this number, 0.3000004. Okay. All right. Okay. We got Boolean values. Okay. This might take a little bit of getting used to, but true and false only has the first letter capitalized. Okay. In R, you might have gotten used to typing in all caps true and all caps false. Those will not be recognized. It'll say all caps true is not defined or something like that. Okay. So here we've got true is a Boolean, okay? That's that. Okay, and then strings. Strings are just encased in quotes. Okay, so if you take a string, you're going to get quote numbers here. Okay, and then lastly we have the none type. Okay, so this is like the null object. The null object meaning that the thing is not there, and that is capital none, capital N-O-N-E, and that's going to be none type. So and then the way to check if something is none is you use the function is, or the operator is none. Okay, and then you ask is n is none, or is n none. This is a question, not a statement. Okay, n is none is true here. Okay, so here's the assignment, n is equal to none, and then this is the question, is it? Okay, and that will return true. Don't use the double equals. Okay, n equal none. It seems to work, and that also returns true, but you know, at a technical level, they're different, and you know, I mean, this will work like 99% of the time, but at a technical level, they are different, and there is a possibility that when you use the double equal sign, or if you use n double equals to none within another type of function or something, it could report the wrong thing. Okay, but anyway, that's what we have there. Okay, and then none is like if you throw it into a like a if statement, it'll get treated as false. Okay, and so if I say if n is equal to true, you know, if it just gets evaluated as false. Okay. All right, let's deal with our first kind of data construct in R, and that will be the list. Okay, and this is kind of our basic thing. So we're going to start off with lists, and then we will quickly move to, well, I don't know how quickly, but eventually, you know, there's other things. So we'll have lists, and then we've got like tuples and dictionaries and stuff like that. And then later on, we will introduce NumPy arrays and pandas data frames. Okay, because arrays and data frames, which would be the equivalent of R vectors in R data frames, aren't data constructs or data structures that exist in base Python, and they have to be extended by importing kind of the modules NumPy and Python and pandas. Okay, so to create a list, you just use square brackets. Okay, and much like the list in R, is that you can throw it mixed data types, so you can mix integers, booleans, strings, whatever you want. Okay, and you can even nest lists inside other lists. Okay, and so here we're creating fam and fam2. I think this is kind of based off of the data camp examples this week for the creation of lists. Okay, and then when you just kind of ask for what are these values, you can see, you know, they print out almost just the way you input them. Okay, with a square bracket, when you see the square bracket, you know you have lists. And then here I've got square brackets and, you know, more square brackets, so we can see this is a list of lists. Okay, subsetting lists is just like subsetting lists or vectors in R. Okay, except the indexes start at 0. Okay, R has indices starting at 1. Over here we start at 0. So fam subset 0 will return back Liz, and fam2 subset 0 will return back the first object, which is the list. Okay, because fam2 is a list of length 4, and each one is a list of 2. So we've got that. And then if I want to get Liz within fam2, I could do fam2 square bracket 0 followed by square bracket 0. Okay, and that will say, you know, the 0 index object and the 0 index object, and that gives me Liz. Okay, and then negative indices will count from the back. Okay, so -1 is 1.89, dad is -2, 1.71 is -3, so on and so forth. Okay, so we have that. Same thing with the list of lists. Okay, and then much like the other things, we can apply kind of sequences of these index characters. Okay, so yeah, just start at 0. Okay. We have slicing lists. Okay, so if you want to get pull out multiple values from a list, you can use the colon operator, and this will create a slice. All right. You can think of, when you do slicing, you can think of saying pull out the items between the comma located at this location and the comma located at this location. So if I say fam slice 1:3, you can treat it as we're going to cut from the first comma to the third comma. Okay, so this is the first comma is after Liz, the third comma is after Emma, and we're going to pull out everything in between. So we're going to get 1.73 in Emma. Okay, and if you do 1:2, then that's going to pull out one number because you're pulling out the item between the first and the second comma. Okay? And if you say 1:1, it's not going to return anything because there's nothing between the first comma and the first comma. Okay, so you can think of slicing as happening at the commas. And then, 0, the 0th comma would be kind of before Liz or something like that. And so with fam2, which is right here between the 0 and the second comma, we pull out the first two elements that we have here. Okay. If you leave off the thing after the colon, it's going to go to the last position. Okay. So fam2:blank will start at the second comma and pull everything to the end. So it's going to take everything from Emma all the way on, okay? And then on the other hand, blank:4 will cut from the beginning up to the fourth comma. So that will be right here at 1.68. Okay, so just think of slicing happening at the commas, and there you go. Okay, if you do a comma with nothing before and after, this is going to extract everything from the list. Okay, and this is effectively the same thing as creating a copy of the list. Okay, so fam blank:blank will create a copy of the list. Okay, and so this is what we have. All right, I put in my notes. In R, you could subset a list, giving a vector of like disjointed values, like I want the first and the third and the seventh or fifth items, okay? And that doesn't exist in Python, okay? You don't have an option for that. We'll talk about list comprehensions later on at a point, but basically the workaround for doing something like that would be running a list comprehension. And you'd have to define the list of the indices, and you would pull, you kind of set up almost like a mini loop inside the definition of a third list, and it pulls out those elements. Okay, this is called the list comprehension, and we'll get to it later. Okay. I think I've got to run these things. Okay, so here's an important thing. In R, whenever you referenced another object, it created a copy of it. Okay, in Python, it creates references. Okay, and so here I create the list fam, okay? And here I'm going to say second is equal to fam. Okay, so I'm creating another list called second, and it's equal to fam. Okay, in R this would create a copy, but this in Python it does not. Okay, so second references the family object. Okay, and so what happens here is that what I'm going to do is I'm going to replace the 0 index object in list second with the word sister. Okay, and so I'm going to say, okay, well, what does sister look like? What does second look like? Okay, so we've replaced the word Liz with the word sister, and then I ask, what does fam look like? Okay, because I said second is equal to fam, they are both referencing the same list. Okay, there's one list, and second and fam reference the same object. So when I ask for what is fam, it has also been modified, and the first word has been changed to sister. Okay, so just be aware that we're referencing objects and we're not creating copies. Okay, so here this is the exact same code, except the only difference here is when I say second is equal to fam, I use square bracket, nothing colon square bracket. Okay, so this is creating a slice of everything, right? So this slices out the list but says give me everything. So it's effectively creating a copy of the list. Okay, so I have fam, and I'm going to say second is this, and so second is now a copy of the family list. I change the first item in second in the second list to sister. Okay, so Liz gets replaced with sister, and when I print that out, that change has been made. If I say what does fam look like, it still shows Liz. Okay, because the second list is a copy, so changing the copy doesn't affect the original list family, the fam list. So that's what we have there. Okay, instead of using doing slicing, you can also do fam.copy, and that's going to do the exact same thing. Okay, so here so in this one, I changed the index 1 object to 1.65, so that gets changed, but fam does not. Okay, so you know, using fam.copy or fam with an empty slice, it does the same thing. Okay, and then you can also use slices to change things. So here I want to, so here is our list fam, okay? And here I'm going to say replace the slice from 1 to 3, okay? The first to the third comma, replace those values with 1.8 and Jenny, okay? And so if I do that, then the slice that exists here gets replaced with 1.8 and Jenny. Maybe I'll so you can use list slicing in conjunction with assignment to change values. Okay. So this is something that's a little, you know, maybe gets a little bit, takes a little time getting used to, but we've got methods that are specific to lists. Okay, so anytime you have a list, you can do this thing .copy. So in our case, it would be like fam.copy or fam.append. Okay, so list copy will create a shallow copy of the list, just like we did here. Okay, family.copy. Okay, and then list.append takes an item and puts it in at the end of the list. Okay, this is equivalent to using slicing and appending the item at the end of the kind of the last slice index here. Okay. So here I have here's our list fam. Okay, and then I use the method fam.append. Okay, and this is going to stick on the word me, the string me, to the end of family. Okay, to the end of the fam list. All right, and unlike R, when you use a method on a list or something, it actually changes the list. Okay, you don't have to capture the output. Okay, so in R, if you like changed something, you had to store the result of that change back into that object or something like that. Okay, here fam.append actually modifies the list fam itself. You know what? I'm gonna change that and do that. Okay, so here when I say append the word me to fam, it actually changed fam. Okay, I didn't have to say fam is equal to fam dot append. Okay, I didn't have to do that. Okay, or you can also append things using the addition operator. Okay, so if you do the addition operator and you provided a list, it will just kind of append the stuff to the end of the list. Okay, so here, this, however, is not a list method, and so you do have to capture the output here. So we do have to say fam is now going to equal fam plus this list item 1.8. Okay, so this output needs to be captured and assigned back to fam, whereas fam.append, we don't need to say fam is equal to fam.append. Is the distinction clear? Okay. All right, we also have insert and extend. Okay, insert will take whatever it is and it will insert at that position, basically at that comma in the into the list. Okay, so if you say insert in position 4, this thing, it'll do that. Okay, so for example, if I do insert Joe, okay, at position 4, it's going to go to the fourth comma, 1, 2, 3, 4, okay, and insert it between 1.68 and mom, okay, and that's what we have. So Joe goes in right here, okay. You might want to be like, okay, I want to insert multiple things, right? I want to take not just Joe, but I also want to take his height or something, right? So we're going to try to insert Joe plus int 2, okay. And if you try to insert multiple items using by inserting a list, it's going to insert a list into the thing. It's not going to keep it at one level. You now have a list. So this is probably not what you wanted. And then if you try to insert multiple items by saying insert Joe, comma 2 here, then it crashes and gives you an error. Okay, so insert can only insert one object at a time. Okay. So the kind of the ways that you can do this is you can do extend, okay, Joe, comma 2, and that will tack on Joe, comma 2 and 2 at the end of the list, okay. Maybe probably the thing that we want to achieve is we're going to use slicing and assignment together, okay? And so here I'm going to say in the slice 4, comma 4, okay, which is right here between 1.68 and mom, then we're going to assign Joe and 2.0, okay? So earlier we saw slice and assignment. Where did it go? Okay, I don't remember. Slice in conjunction with assignment. It happened somewhere. Okay. Where the slice that we were replacing was the same length as what we were assigning. Okay. But you can also have the thing that you're inserting be a different length than the slice itself, and you're basically extending or expanding the list out. Okay. So you can do stuff like that. Okay. Earlier we talked about making a shallow copy, okay, using list.copy. Okay, so when I did like fam.copy, this creates a shallow copy. All right, so then you might ask, well, what's a shallow copy? And is there such a thing as a deep copy? And yes, there is such a thing as a deep copy and a shallow copy. Okay, so list.copy is the shallow copy, and then you have to import the copy module, and from copy you can use deep copy, and that's going to create a deep copy. Okay, so what's the difference? All right, the difference happens if the list is referencing other objects. Okay, so here I have a list A, which is A12, and I have a list B, which is B34. Okay, and I'm going to create a list C, which is references list A and list B. Okay. And so if I do D equals C, this is not a copy where D and C both refer to the same object here. And so when I ask what's C, it's going to be A12 and B34, A12, and D is A12 and B34. Okay. And then if I say, all right, let's change index 1 of list C to X, this affects both C and D. Okay, because that's not a copy. All right, let me show you the shallow copy. Okay, shallow copy, the same thing. D is going to be a shallow copy of X. So if I replace index 1 with X and C, D is unaffected. Okay, because C references list A and list B, but I replaced the item at index 1 with X, and so so that changes in C. Okay, but D is unaffected because D is a copy. All right. However, both of these things reference list A, right? And so if I modify list A by using append, I'm going to say a.append, let's append the number 100, okay? The value for A, the list A is modified, and so C and D, which reference list A, are both modified, okay? So C now is A12 100 in X, okay? And then B, which used to be this, A12 B34, is now A12 100 and B34, okay? So that's a shallow copy because the copy of C copied the reference to object A, all right? On the other hand, we have a deep copy. So I do the same thing, okay? A12, B34, C is references lists A and B. And then we're going to create list E. E is a deep copy of C. Okay? Same thing before, if I change index 1 of C to X, it affects C, but it doesn't affect E, because E is a copy. All right? And this is the difference between the deep copy and the shallow copy. I'm modifying list A by appending the value 100 to it. Okay? When I modify list A, C, which references list A, is modified when I modify A. Okay? E, however, created a deep copy. So it doesn't reference list A. It created a copy of list A that's unnamed, but it remains as A12. Okay? So the shallow copy will copy references. The deep copy copies the actual object that is being referenced. Okay, which if you have things that are nested and deep references and all sorts of references to references to references, the deep copy computationally takes a little bit longer to execute. Not that it probably most of your smaller things aren't going to be affected, but and so that's just something to keep in mind. The default copy method is a shallow copy, which copies references. And so if the object that's being referenced is modified, it's going to be modified in all copies that still reference that same object. Okay, that's the aside on copy versus deep copy. Okay, we'll I don't know. Okay, we'll see how far we get. Okay. We also have pop, okay, and remove and clear. Okay, so remove will just take the item out of the list. Okay, this modifies the list itself. You don't have to recapture the input. All of these things modify the list itself. Okay, so fam is this. If we remove Liz, Liz has been removed from the family list. Okay. If we pop, okay, pop will remove the object, and it starts off with the last thing. Okay, so it pops it off. Okay, it takes it out, but it also returns the value of the object. Okay, so so you can capture the result of fam.pop. Okay. Fam.pop itself is going to be the value that got popped off. Okay, so here the family is this list where 1.89 is the last value. When I call fam.pop and I capture that output as j takes on the value 1.89. Okay, and fam has been modified and it has lost that last value. Okay, you can specify an index. Okay. And so, so in this case, so the default behavior of pop is kind of like a stack, which is last in, first out, right? So if you have a stack and you just put in 1.89, and you do pop, that's going to be the first thing going out. Okay, but if you want, what's the other thing called? What? A queue, yes. Okay, first in, first out. Okay, then you can specify, you can use pop, but then you would specify index 0. Okay, and then the first thing that goes in, if you do pop 0, it'll pull out the object at index 0, and it'll get pushed out. Okay, and so in this case, but you can specify any index you want, and so you have Liz 173 Emma. And here, if I do fam.pop2, Emma is going to get thrown out, okay? And so J will capture the value Emma, and fam no longer has the value Emma, okay? And then the last thing, fam.clear, takes the list and it just clears everything out of it, okay? Okay, maybe I guess we'll just end here, and then I can just talk about this other stuff on Monday. Okay, so on Monday, we'll have a short quiz on Git, kind of your basic commands: git add, git commit, git push. Know some of the options that you'd want to use, and we'll go from there. Okay, all right. We'll see you then. Have a good weekend.